All right, I'm going to do question 3.41 from our textbook. In this question, we have a candy company that distributes boxes of chocolates with a mixture of creams, toffees, and cordials. Suppose that the weight of each box is 1 kilogram, but the individual weights of the creams, toffees, and cordial may vary from box to box. Okay, so for a randomly selected box, let X and Y represent the weight of the creams and toffees. So notice that they don't say X, Y, and Z, right? Why is that? You don't need, once you know the weight of the creams and toffees, and the entire box is 1 kilogram, well, the leftover weight is the weight of the cordials, right? That makes sense? Okay. So this is the probability distribution function. Notice that there's this interesting support, right? And whenever you see support that's this interesting, you're definitely going to want to graph it. Actually, when you're new to statistics, I always think graphing your support of your probability distribution functions is always a great idea. But particularly when the support is complicated like this, you definitely want to graph it, okay? The first question is to find the probability that in a given box, the cordials account for more than half of the weight of the box. Okay, so let's go ahead and start with just graphing the support. So let's see it. So the first thing is that X, this is X, right? This is Y. X travels between 0 and 1. Okay, so here, we'll put 1 here. So X is between 0 and 1. Y is also between 0 and 1. Okay, then X plus Y is less than 1. All right, how do I graph that? Less than, between 0 and 1, between 0 and 1. Those are easy, but this one is a little more difficult, but we can think it through. So X plus Y is less than or equal to 1. Right, usually I graph equations with Y on the left-hand side. So let's go ahead and move that X over. Okay, so now the intercept is 1, okay, and -1 is the slope. So I'll go -1 is my slope. All right, and Y is less than that line, right? So that means, because Y is also greater than 0, right, that we are bounded here. Okay, so if you were to integrate over this entire triangle, if you were to integrate this joint probability distribution function over this entire triangle, you should get 1. Basically, like shooting out from the page here is on top of this, that's where the joint probability distribution function is. And so the area underneath that shape is 1, right? So this is basically if you were to project down onto the XY plane. Okay, and really that's all that matters. We'll just be thinking about this as if we're integrating over this space, right? Everywhere else, the probability distribution f of xy is 0. Okay, so in part A, right, we're trying to find the probability that for a given box, the cordials account for more than half the weight. Okay, so let's think about that. Now, let's say, Z is the weight of the cordials, right? So Z plus X plus Y equals 1, right? So Z then is, if Z is less than half, Z is more than half, right? So the weight of the cordials is more than half, then that would mean that X plus Y would have to be less than half. Less than or equal to half, right? This makes sense, right? The cordials, it's more than half of the box, or half of the weight of the box. The box is only 1 kilogram, so it's more than half a kilogram. So that implies that the weight of the chocolate, or the weight of the creams and toffees must be less than a half. less than or equal to half. Okay, so that's what I'm going to write here. This is the probability we're trying to find. Okay, so now let us figure out where this is, where we'll be integrating over in order to find this probability. It will be a piece of this triangle, okay? So let's see. Again, I usually graph things with y on one side, right? So x plus y is less than or equal to half. So let's go ahead and move y to one side. So that's the same thing as y is less than a half minus x, right? Just move the x over to the other side. Okay, so here's a half. That's my intercept. My slope is -1. So here we go. All right, and y is less than it, so that means I go down. Okay, y still has to be greater than 1, right? That's part of the constraints, and then yellow. Okay, so, and x also has to be greater than 0. So, did I say 1 more than 0 is what I meant to say, right? So we're restricted to this little triangle. This little triangle. So this is the little triangle we want to integrate over right now to find this probability. Okay, so let's integrate over it. The order of the integration doesn't matter. You could do dy dx or dx dy. However, whatever order of integration you choose, it needs to match you dx dy, then this order needs to match. Okay? So I'll go ahead and do it dx dy because that's what people usually do out of convention, but like I said, it doesn't matter which way you want to do it. Okay, so now if I'm thinking about where x travels on this triangle, remember x moves from left to right or right to left, right? Well, left to right, left to right. So it starts at 0 on this triangle, right? No matter where, it always starts at 0. But where does it go to? Where does x go to? It goes to this line here. Okay, so x travels to that line. Now, what is that line with regards to x, right? So this goes from x equals 0 to x equals what? What is that line? Well, let me rearrange this equation to solve for x, right? So x is less than 1/2 if I subtract y from both sides, 1/2 minus y. Okay, so there we go, 1/2 minus y. All right, now now with regards to y, where does y? Now when you're thinking about the outer bounds, you have to consider the fact that you've already integrated out x. That is very important, okay? So since we've already integrated out x, you don't need to, you're not bounded by it. So just think of the total range for y in this triangle, right? So y travels from y equals 0 without any regards to x. It travels all the way up into y equals 1/2, right? This point here is y equals 1/2. All right, so this will be, and what am I integrating? I'm integrating my joint probability distribution function. All right, I think I did this integration in Blackboard already in an image, so I'll leave it there. This is the way you set it up. That's the most difficult thing, is how do I set it up? You can also set it up in terms of dy dx. I'll talk about that really briefly, actually. So if you do dy dx, then you first consider where does y travel, and this time you do have to, since it's the inner bound, you are restrained by x, okay? So when I go up and down like this, when I go actually from down to up, where does y go? Y goes from 0 until I get to this line, right? So y goes from 0 till I get to this line. So in the inner bounds, I do need to consider x. So I would go from 0 until I get to that line. That line is 1/2 minus x. Okay, and then where does x go once y is already integrated out? Once y is already integrated out, x is traveling between 0 and 1/2. Okay, so you can set it up, and if you solve both these, you should get the same answer. I believe the answer is 1/16. So I'll go ahead and leave it there. If you have any further questions about how to do this integration, just please let me know, and I will post again.